All right, guys, today's goal is to focus on being able to graph the graphs of equations, okay? So using a t-table. So here they've given you 3 points. So what do? We plug them in. And we calculate. Now here's the thing I want to talk about. Notice the denominator's 2. So don't use numbers like -1 or 1. Use even numbers because they just cancel out. So this is going to be 3 plus 3 is 6 because a negative times a negative is a positive. So you get 6. If you plug in 0, you get 3. If you plug in 2, you get 0. So then we graph them. So graph -2, 6. Graph 0, 3. And then graph 2, 0. They are a line. Okay. So let's take a look at another one. Now here they went -3, 0, 3, and you can just plug them in if you want. I would solve for y, so sorry about that. So I'd add the y over, and you get 2x equals y plus 3, and then subtract the 3. So you get 2x minus 3 equals y. Now plug in the x, so you'd have 2 times -3 minus 3 equals -6 minus 3, -9. 0, you get -3, and 3, you get 3. So again, what we need to do is graph these points. So if we get a graph -3, -9, 0, -3, and 3, 3. So hopefully this is refreshing and we're all remembering how to plug in values and graph lines. Okay, let's take a look at the next. Alright, so again, another t-table method. Just plug them in, calculate. So you get -6 plus 3, 3. 3, hold on. That should be -3. And then plug in 2, you get 6 plus 3 is 9. So this one's kind of the opposite. So you go -2, -3, 0, 3, 2, 9. Okay. Now, next thing we're going to be talking about, it says without graphing, find the x-intercepts. Okay, x-intercept means plug 0 in for y, solve for x. So 2 times 0 plus 5x equals 6. So you have 5x equals 6, divide by 5, x equals 6/5. So the x-intercept is 6/5. Notice, no decimals, comma 0. We don't do decimals, guys. The y-intercept is plug 0 in for x, solve for y. So the value is y equals 3, and it's the point 0, comma 3. Okay? So let's take a look at some more. Alright, here it says without graphing, find the intercepts again. So remember, x-intercept. Plug 0 in for y. Solve for x. So subtract the 3. Multiply by the reciprocal. Put it over 1. Negative times negative is positive. You get x equals 2. So you had the point 2 comma 0. The y-intercept, plug 0 in for y, x, solve for y. Plug 0 in for x, solve for y, so you get y equals 3. So you have 0 comma 3. Okay, if we compare this back to the first graph, we did a t-table, we'll see these calculated intercept points are the same points. So yeah, I mean, we've done it before, we're all good. So let's take a look at some more. It says we can graph equations by using the intercept points that we calculate. Usually required to have 3 because you get a much more exact graph. However, when you graph intercepts, we'll just use 2. So if we graph by the intercepts, remember, plug 0 in for y. Solve for x. The other one, plug 0 in for x. Solve for y. So here you have 3/4 comma 0. Here you have 0 comma 3. So those are the 2 points we have to graph. So let's graph those. So I zoomed in a little bit there so I could graph the 3/4 comma 0 approximately, and then 0, 3. So there's the line. Okay? So let's take a look at some more examples. Okay, so here it says graph the equation. When you find the x-intercept, it's 0, and you get 0. So the problem with that is our point, we only have one point to graph because it went through the intercept, so you need to get some more values. So if we look back at our table, we're plugging in negative 4 and positive 4. So 3 times negative 4 plus 4y equals 0. So you get 4y equals 12, so you get y equals 3. And this is going to be a negative 3. So you go negative 4, 3. And then you go 4, negative 3. So there's your line. Okay? Let's talk about a couple special cases you should remember. Alright, we have special cases of x equals 5 and y equals 3. X equals 5. That means you go to where x is 5, and it's a vertical line. Y equals 3. You go to where y is 3, and it's the horizontal line. Okay? So just remember those. Y equals 3 is always horizontal. X equals 5 is always vertical. Okay? Alright, let's take a look at some more examples. Everyone's favorite, the word problem. So it says a new limousine costs $55,000. It will depreciate over 10 years. At the end of the 10 years, the value of the limousine is now $10,000. So it says write an equation of the straight line depreciation of the limousine. Find the y-intercept of this model. Graph the model of the value of the limo. Use the straight line depreciation business model to find the value. Keep in mind that straight line depreciation happens evenly over time. So we want to use y is the final value, t is the time. Okay? So here's the thing. The equation, we already have the y-intercept because it's the beginning cost, because when t is 0, it is valued at 55,000. So now we need to find the slope, but we know that end of the 10 years it's now 10,000. So we know 0, 55,000, and 10, 10,000. So if you think about this, 10,000 minus 55,000, because that's how much it's gone down, divided by 10 years. Okay? So you get that the slope is going to be negative 4,500. So our equation is y equals negative 4,500 t plus 55,000. Use that to find after 5 years, meaning substitute in 5 for the t and calculate it out. If you do that, you should get 32,500. So if we look at our graph below now, so see how we have a couple key pieces to talk about here. Time in years, labeled. Okay, so the time in years here, pretty easy to label. So those we can just go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and just 1, 2, 3. Now here, let's say we're going to do 10 years because we have 0 to 10 here. Well, that's fine. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But we need to do the 55,000 divided by the 10 to get, you're moving in increments of 5,500. Okay? So graph those points. You go 0, 55,000. Let's do a different. So next we need to go to 5 years. And then approximately 32,500, which is going to be just below this because this is 3,300 basis. So if we go just below that and then out to 5 years, and then you're going to be at 10. It's going to be a little below that. So the reason it's off is because we don't have a graph paper for the scale, but so there's our line, but it's going to stop here because it's never going to be word negative. So okay, so we already did that, so we've got that going. So we'll see you guys tomorrow.